Let's get back into core JavaScript features, and there let's dive deeper into functions. We used functions quite a lot already. They're everywhere. They're a super important concept or construct in JavaScript and basically in any programming language. But there's more we can do, or more different ways of configuring and using functions than what we covered thus far. To be precise in this module, after a very brief refresher of what we already know about functions, we'll dive into different ways of creating functions because there's more than the one single way we know thus far. We'll have a closer look at anonymous functions, something I briefly touched on in the behind the scenes module, but I didn't really explain what that is and why we might want to use that, and we'll do all of that in this module, of course. We'll have a look at callback functions and functions in functions. Yes, that is possible. You can define a function inside of a function, and here we'll have a look at how that works. And we'll have a look at default arguments and the so-called REST operator, what that is and why we might want to use it. And last but not least, there is a special built-in function, you could say, a couple of built-in functions actually, the bind function and some related functions, and I'll touch on those and explain what they do and why we could need them. So with that, that's the content. Let's dive right in. So first, a quick summary. What do we already know about functions? Functions are these constructs which allow us to define code on demand. And when JavaScript reads our script, it basically goes through the entire script first, finds all these function declarations which we added, registers them, and then it really starts executing the script. And we can call our functions as often as we want, so we have code which we can execute multiple times from different places in our program. You also learned that if you create variables or constants inside of a function, they belong to that function because of that block scope thing covered in the last module. Functions can take parameters, also called arguments, and can return a value. They have to do neither of that, and they can take as any parameters if you want, if you need them, but you can also write functions that do neither take parameters nor return anything. As I mentioned, functions can be called multiple times, and of course you typically would pass different values for these arguments then, because that's the cool thing about a function. It's code on demand, and it is able to be dynamic because it can take arguments, and the arguments can differ from function call to function call. So the same function will typically produce different results for different calls because of different arguments, for example. And you can also call functions kind of directly or indirectly, where directly was when you called a function by adding parentheses after the function name, and indirectly was, for example, the case when you bound or when you attached a function to a button with the help of the add event listener call, which you saw. So that's what we already know. Now let's see what we can learn about functions. Now for this module, again, let's work with a simple program. And for this attached, you find that starting code, a zip file with an index.html file and an app.js file. The index.html file is relatively lean. We got a button in there and that's it. Get the script import in here. As you can tell by the title, we're going to build a rock, paper, scissors game here, very basic game. Most of the interaction will happen with the help of alerts and prompts and in the console. But we do have that button to start the game. And in the app.js file, which is getting imported here, we basically got an empty file. The only thing I added for you is this access to the button, which allows us to add an event listener. Now, speaking of that, we can, of course, add a function, maybe name it start game, as you learned it with the function keyword, then the name, list of parameters, here I don't need any, and then the function body where you can put your code. And then you can call that function like this, and what this would do, of course, is that if we output game is starting here, just like that, we save that, and we then reload this page, load this page, visit the index.html file. We essentially see the game is starting output here in the console. Clicking the button here doesn't do anything because, well, we didn't connect this function to the button, we just execute it like this. This would be this so-called direct execution, which I meant. Now, on the other hand, you can also go to the start game button and add an event listener, click listener here, and point at the start game function. Then you don't add parentheses here. Instead, you just give the add event listener function here the name of the function, and behind the scenes that will do the wire up work and make sure that this function gets called when a click occurs. Now if we do that, then we actually see there is no output right now, but if I click the button, there is. This is this indirect execution. Now the first important thing which I want to highlight here, or which I want to dive in, is this add event listener function actually. This is not a function defined by us. Instead, it's in the end provided by the browser. But we don't call it like this. Instead, we call it on this start game button, which seems to be an object because we use this dot notation. Now you learned that objects can have properties. You can have something like a person object with a name property like this, and then you can always access person.name to, for example, output that, right? So that's the syntax you learned. This is something we know. Now here we also use the dot notation, but what we then do is we don't access a property, we're not logging it or doing some calculation with it. Instead, we execute it as a function. And indeed, functions can be stored inside of objects as well. If we add our person here, and I add a greet property, let's say, like a normal property, thus far nothing special, then instead of just having a value here on the right, something like max or a number or even another object, you can also put a function here. For example, a function greet, and there we could say hello there. This would be a basic function stored in an object. Now, the only special thing here really is that on the right side of our key value pair, so after the colon, we don't have a value which we used thus far to store it in a variable, but instead here we have a function. Now, that's of course a different use of function, because thus far we always created a function standalone. We're not storing this function anywhere. We just create it like this, and this automatically creates this start game thing, which JavaScript registers, which we then later can use by its name. Here, I also do that, but then this seems to be stored in here. And indeed, if we now execute person.greet and we add parentheses here, we can execute this as a normal function. If I save that and reload this page, we see hello there. So indeed, we can store a function in an object, and that is then called a method. It's just a term for it. Just as we name a variable in an object, like name, just as we name this a property, even though in the end it's a bit like storing a value in a variable, just without an equal sign, but that's then called a property. Well, if you store a function in such a property, so in a key in an object, then you call it a method. But a method is nothing else than a function attached to an object, you could say. And add event listener, therefore, is a method on this start game button object. And this is an object generated for us by JavaScript by calling this method up here, the getElementById method, which exists on this document thing. The document thing here, by the way, is a globally available variable in the end, which gives us access to our HTML document. But more on that in a separate module where we dive into how we can interact with the HTML code. That's not the focus of this module. But this in the end is a method which in the end generates or gives us this object which we store in start game button. So an object which represents this button, so to say. And this in turn then has this add event listener method, which we can call to register an event listener. So storing functions in objects is possible. You call them like this, and they're then basically methods. You call them methods if they're stored in objects. So that's our first important thing. I'll comment this out now because we don't need it for the game, but I wanted to mention it that you can have functions in objects and they're then called methods. So functions in objects is a thing. What if I would tell you that functions themselves also are objects? I can prove this. If I console log type of start game, you might remember this type of operator. We used it earlier in the course to find out what the type of an array and of a number and so on is. Now, if I log the type of my start game function, so I'm not executing it because that would call the function and I would get the type of whatever this function returns, which is nothing, which therefore would be undefined. As you see, if you reload, you see undefined here. So that's not what I'm interested in. If I log it like this, I'm basically doing the same as with the event listener. I'm just passing the name here, and therefore the type of operator will have a look at the thing behind the name. So it will have a look at that thing which is stored in start game, which is our function. And if we do that, if I log the type of my function here, then if I reload, you see function here. Okay, that's not an object, right? That's a function. Well, actually, function is a separate type which is being logged here, but it's based on object. It becomes a bit easier to see if I don't log the type, but the function like this. So I'm not calling the function, I'm just passing the name here. So therefore I log the thing behind the function. Now let's also switch console log to console dir, which gives us a different insight into objects. And if we then go back and reload here, you see, okay, we get this strange thing here, looks like a function, but I can expand it, and what you see here is actually, there's a bunch of strange stuff in it. We got a name, for example, we got an arguments thing, and these are all key value pairs in there. So these are all properties of this function in the end. Now it also has a scopes thing, and that's interesting. This basically tells JavaScript where to manage the variables of this function, so what the scope and so on is. And we don't need to worry too much about the stuff that's in there. Some of the things, like prototype, will become clearer later in the course, once we dive way deeper into objects and how they work internally. Not something we have to worry about right now. The only key takeaway right now is that a function in the end, whilst having its own type, is an object. It's basically also an object, a special type of object, if you will, with special pre-configured properties, but still an object. And the implication of that is, for example, that it's typically stored in the heap, as you learned, and basically anything that applies to objects, for example, that they're reference types, also applies to functions. Often that might not really matter to you, it's still important to be aware of that. So functions are objects. So now that we know that functions are objects and that we can also store functions in objects, which essentially stores an object in an object, I guess, but an object which can be executed as a function. Now that we know that, let's dive into a different way of creating functions. This code here, where I stored a function in an object, is a bit strange because effectively here, we're creating that function on the right side of an assignment operator. The colon here is doing nothing else than assigning this or this value to this or this key, right? So it's a bit like if we would say, well, we store this function, let's say, in a constant named start or start game or whatever you want to name it. Doesn't have to be the same name as here. It is like if I would do that. Now, if I do that and I reload, we'll get an error. Start game is not defined, and this is coming from line 18. So now this line here at the bottom complains that it can't find the start game function anymore, even though it exists. Now it's interesting to note that we didn't get any other error though. So JavaScript does not complain that we use this on the right side of an equal sign. Now that's not something you should take for granted because, for example, if we try to use a if statement on the right side, then JavaScript will complain. Even the IDE already complains that this is not allowed. So it's not something we should take for granted that we can take a function on the right side of an equal sign. It's something special indeed. It's something which we can do in JavaScript. Now we store this function object, which it in the end is, in this start constant. The implication of that, however, is a very important one. Previously, when not doing that, JavaScript went through our file and registered all functions, no matter where we placed them, even if we placed them below the place where we used them, and was aware of them. It stored these objects in some place, in a global scope in the end, right? So we could call start game here. Now, when we store it in this variable here, the implication is that this function is still created, but it's not stored under this name here in the global scope anymore. Instead, this is just some kind of internal name which is attached to the function, but which is not available in the global scope. But instead, it's now stored in this constant. So if we would want to call this function here now, we can also call it like this. We have to refer to start down there. So to this start constant or whatever you named this constant. So if you named that start game, which you can do, you can use the same name as here. This will not clash because, as I just explained, this will not be stored in the global scope anymore when this is on the right side. So you can use start game. Well, then obviously you can keep start game down there too. But if you use a different name, which obviously is better for explaining this here, then you see you have to use that name down there. And if you do so, and you save that and you reload, it will work again. So you can store functions in variables or constants. What you're doing here in the end is you're using this function as an expression instead of as a declaration. So here we're using this function as a declaration, as a statement. Here, since it's on the right side of the equal sign, we just use it as an expression. Remember, expressions were essentially the thing that yielded you values, so something you could store somewhere else. I mentioned that earlier as well. So now we're creating a function in this expression mode, and therefore it generates a function object, just as it did before, but the difference is that JavaScript will not go ahead and take that object and store it in the global scope for us in the end, under that name, but that instead we just store it in this variable. That variable, or that constant here, is then stored in the global scope, but we can therefore now only reference this function by using that variable or constant name. This is something we can do. And now we can also omit this name here if we want to, because we don't really need it here, right? We can't reference that function by that name anyways, and hence we can also omit it. This now is a so-called anonymous function, and typically you then place the parentheses right after the function keyword without a white space. Technically it doesn't make a difference, it's just some code style. And important, when using this function expression with or without a name, you also typically add a semicolon after it. You could do that after a function declaration as we used it before as well, but there you typically avoid it because it's like a statement. But here, if it's on the right side, the convention is to add this semicolon. So now if we do that, this will still work as before, as you can tell. But now we also created a so-called anonymous function. Now the concept of having an anonymous function is detached from the concept of storing a function, a constant. We can use anonymous functions in different places as well, and I'll show you such a place in just a second. I just wanted to introduce it here as well. But let's actually take a step back from that and ignore the anonymous function thing right now and just have a look at this function expression versus function declaration, function statement thing. Why would you use that instead of the other syntax? Well, if we compare both, we have the function declaration, function statement, which looked like this, and the function expression like this, which I just showed you. Of course, needless to say, in function expression form here, you can also still take arguments and still return values. That didn't change. Now, the important difference to what it really boils down here is that for this function declaration, function statement syntax, JavaScript automatically hoists the function to the top and then also fully initializes it for you. So what I mentioned, JavaScript reads the file, and no matter where you define your function, it acts as if it would be defined at the top of the file, which means you can actually call functions before you declare them. That can be convenient, and if your code style is to always have the functions at the end of the file, then you have to use this approach. With function expressions, this hoisting is also working, but the constant gets hoisted, but it gets hoisted as undefined. Something I also had a look at in this behind the scenes module. So it's basically not initialized, so you can't call the function before you defined it. And that's an important difference. You have to define, you have to initialize your functions before you try calling them. And in my opinion, this is a bit of a cleaner style, though you will find both code styles. I will say that. It's not strictly better or worse than the other. I personally prefer this approach a little bit. I think being forced to define functions before you use them is a great thing. But of course, it's needless to say that you could also simply define functions with the left approach before you use them. So you don't have to use the right approach just because you want to do that. The right approach just forces you to define functions before you call them. Now, ultimately, it's therefore up to you which one you prefer. I'm personally a fan of the right approach, but as I said, both works and both can be used. There is no bad approach here. Just to also quickly demonstrate what I meant, here we have this function defined. Now, if I would call start here, before that definition, if I save that and reload, I get an error that we cannot access start before initialization. And we wouldn't get that error if I had my function start here, let's say like that. So in this declaration, in this statement syntax. If I would do that, this would work just fine. As I mentioned, because JavaScript reads the entire file, and if it finds function declarations like this, it kind of acts like they were at the top of the file. So that is an important difference. as I mentioned, this is the style I prefer, but not a style you absolutely have to use necessarily. So let's come back to that anonymous function thing. Here, I created an anonymous function. We could have assigned a name, as you saw. It doesn't matter here. And I'll come back to what a tiny difference is in a second. But we can also create it like this, because we don't really need the name here. Now, that's one place where you could use anonymous functions, because you store them in a variable, and then the name of the variable is the name by which you call and by which you reference the function, as we're doing it down there when we add the event listener. So that's one thing. But you can also use anonymous functions in places where you don't even store them in variables. And one place would exactly be a scenario like this one, where you add an event listener. You might add an event listener here, and you can do so by defining an anonymous function in place here where you need it. Now, important, this is basically the same as if you define it before and stored it in some variable, and then just reference the variable here. This will not immediately execute the function. Why would it? There are no parentheses after it, which you, by the way, could write. This is valid JavaScript syntax. This would now immediately execute the anonymous function. But this is not what we do here. This is not what we need here. Instead, this just creates a function in place and kind of passes the reference of this anonymous, on-the-fly created function to add event listener. Now, why would we do that? Because maybe we have no other place in our entire code where we ever need that function again. Indeed, that's actually the case for start here. I can comment this out. I will only call it when I click this button here. So I will just move my code, which I had in there, into this anonymous function, and I'm fine. There is nothing wrong with having a separate function. And as you learned in the behind the scenes module, there might even be some memory leak considerations you want to take into account. But if you know you only add an event listener once here, then this doesn't really matter. So there is no way of creating a memory leak here. And then it just saves us some code. And if someone else reads your code, he or she doesn't have to find that function you're referencing here. So if I read that, for example, I have to look where the start function is. There it is. So I don't have to do that if you use an anonymous function. Instead, everything is defined in place here. And by just looking at this line, I fully understand what's going to happen when this button is clicked. So this is a prominent scenario for using an anonymous function. Event listeners, or any use cases where you pass a function, a reference to a function, to another function, which is effectively what we're doing here, right? We're passing a reference to this anonymous function, or before to the start function, to this add event listener function. So this function actually takes a function as an argument, if you think about it like this. Something we'll also have a closer look at in this module. And therefore, this is a great scenario for using such an anonymous function if you never need that same function in any other place in your code. So if I save that and we reload, you will see that works just fine. So I can click this button because my event listener was added with this anonymous function. So why might you still assign a name to this anonymous function though? Because maybe that function throws an error. Let's say here, I'm also trying to log age, which is a variable which just doesn't exist, neither locally in that anonymous function, because of course anonymous functions, just like other functions, have their own local scope. So neither there nor globally, nor in any other file. So age here doesn't work. Side note, name would work because there's a default name global variable available in your script made available by the browser. So don't use name here, but age will not be available. And therefore, if I reload here and I click the button, I get an error. Now, what you'll see is, if you want to find that error, of course, it gives us the line number, so that helps us. But what we don't see here is the name of the function where this problem occurred. Now, since we have the line number, that might not matter, but if you have a huge script and maybe you're even running some automatically optimized version here in the browser where the line number, which is shown here, might not meet the line number you have in your code, then it would be nice to see the function name here, and we don't. Now, that's different if we use a function defined in the old school style, and old school is kind of a dangerous word because it's perfectly fine to use that. But if I would define my function like this, so not storing it in a constant or a variable, but just declaring it like this, and I had the same code in here, and I would then temporarily replace this anonymous function with that, then you will see if we do this, and we therefore encounter the same error, it actually gives us a hint at the function name here. It mentions that this is the start function. On the other hand, when using an anonymous function here, so if I revert all of that, if I use that anonymous function as we did before and we reload and we reproduce this error, here it says anonymous because, well, that's what it is, an anonymous function. Now we can mitigate this by giving this a name, start game or whatever you want. You can't call this function by that name as you learned. It's not declared and managed globally by JavaScript, but that name is used for debugging, for throwing errors by the browser. So if I now reload this and I produce this, you see start game here. So that's a reason why you might want to give your anonymous functions a name. You don't have to. Obviously, with the line number, we would have found the problematic line as well. But it is worth a thought. And this is why you might still want to assign names to your anonymous functions. Here, I don't really need it because I don't plan on adding this error here. So I'm fine like this. But that's just a tiny additional thing you should know about anonymous functions. So thus far we haven't progressed too much into our game, so let's work on that. I'll get rid of that old code up there, of the commented out code, so that we just have our event listener and so on. And now in between we need a couple of other functions which we can kick off when our game started. When the game started, we want to let the user choose whether he wants to use rock, paper, or scissors. That's the game, right? Now, for that, we can add a new function, and I'll use that approach where I store it in a constant. Again, totally optional. Though for now, I would recommend that you also use that, because we'll tweak this a little bit in a second. So I'll create a constant and name it getPlayerChoice, because this effectively is now my function name, so it should also be named like you would name functions. And I'll store an anonymous function in there. Now getPlayerChoice should show a prompt to the user asking for rock, paper, or scissors, right? So we can get a selection stored in a constant by using the prompt function, which is built into JavaScript, and ask for rock, paper, or scissors. And provide a default value of an empty string. So now that will open a prompt to the user when we call that function and store the result in selection. Now obviously, the user could enter anything in there, so I want to check if selection is not equal to rock, and selection also is not equal to paper, and selection also is not equal to scissors. If that's the case, and we can structure this across multiple lines and avoid typos here, so if we add this if check, and we make it into this if block here, I know that something invalid was entered because the user obviously neither entered rock, nor paper, nor scissors. So in that case, I want to let the user know that he or she made an invalid choice, and that will use some default for him or her. Of course, we could let the user choose again, but I want to use a default in that case. We chose rock for you. Let's say rock is our default here. Now, a little adjustment right away. I want to work with some constants, some global constants here, so that when I use rock, paper, and scissors as words in my if statements, I can't introduce typos. That's a pattern I showed you in the control structures module. So here I just will introduce some global constants. Selection rock, which is rock, or maybe just rock actually. We can shorten this. And duplicate this, and then also here have paper, and also here have scissors. And the advantage of this is that now here I can use rock, here I can use paper, and here I can use scissors, and I can't mistype. And we can even use that here in our template literal and ask for rock. Now, of course, the user has to enter this all in capital cases. Paper or scissors. Now, to make sure that we don't dismiss a choice as invalid just because the user maybe entered rock instead of rock, we can actually also convert the entire string the user entered to all capital case. And we can do so by calling to uppercase on the return value of prompt. Now, the return value of prompt is a string, as you learned. And as you learned, objects can have functions, can have methods. Now, you also learned that strings are primitive values and not really objects, but in that same video where you learned this, I mentioned that you can still access certain properties and functions on these primitive values, and they're kind of temporarily used as objects, you could say. It's a bit more complex. JavaScript does this behind the scenes for us, so we can use them like objects, but they're not really objects. That's how you can think about it. So a string is a primitive value, but it still has this toUpperCase method, which it exposes to us. So it exposes this method to us, and what this method does is it returns a new string where all characters have been converted to uppercase characters. So what we store in selection will be a string with only uppercase characters, and then we can use that here in that if check. So in here, we now check for a valid selection, and if the selection is invalid, we let the user know that we chose rock for him or her. So actually we can use a template literal here as well and output rock here as well. Maybe even create a new constant, default user choice, and set this equal to rock, so that here I refer to that, and if we ever would want to change that default choice, we only have to do it up here. And with that, we validated this. Of course, I now want to return here. So here I can return rock, or to be precise, default user choice. Otherwise, if we don't make it in here, I want to return selection, which should be rock, paper, or scissors. So now here in this anonymous function, we can call getPlayerChoice, and this will return us whatever the user chose or that default selection. And hence here, I'll store this in a new constant named playerSelection, which is now a local constant of this anonymous function. So for now, let's just log this here and see whether it works. So let's log the playerSelection here and have a look at that. If we save this, we go back and we reload this page here, click on Start Game, and we get this prompt. And if I enter something here and click OK, I get invalid choice. We chose rock for you, and hence rock is being printed here. If we reload this and I click again, and I enter rock here, I get rock. And just to prove that also something else works, if I enter paper here, I get paper. So that works. Now, before we continue, I also want to make sure that once we started a game, we can't start another game. And for this, I'll add a global variable, game is running, and set this to false initially, but set it to true in this anonymous function, game is running, set it to true. But also here, before I set this to true, check if game is running. And if the game is running, and we don't need to add equal true here, because there already is a boolean in game is running, or something which can be coerced to a boolean value, but it already is a boolean. So we'll make it in here if game is running is true, and then I just want to return, so that when we click the button again and again, we don't start new games. Of course, right now we're not doing too much in our game though, so that's something we'll have to change, but we'll get there. So we started the game, we allowed the user to make a selection. The next step, of course, is that the computer also is able to make a selection. Before we do that, however, let's see how else we can create functions, because it turns out there is yet another way of creating a function. So let's now continue and make sure that the computer also makes a choice. So for that, we can add a new function here, getComputerChoice, an anonymous function stored in this constant here. And there I want to calculate a random number between 0 and 1. And if it's between 0 and .33, let's say that's rock. If it's between .34 and .67, it's scissors, and so on. So that a third of that range is reserved for every choice. So we can get the random value here, store it in a constant of any name of your choice. With moth random, we haven't really used that before. Moth is a globally available object, you could say, made available by the browser in JavaScript. And it has a random method which generates a random number between 0 and 1. Now we can add an if check here and see if the random value is, let's say, smaller than .34. In that case, let's say the choice is rock. So here we can return rock. And since we return, this function will then stop at this point, of course. Else if, let's say the random value is smaller than 0.67, which we only reach if this was false. So this will not kick in for a value like 0.2, because of course that would be true for that value, but so is this. And since we handle this true value here already, this other else if block will not kick in, no matter if we return here or not. So if we are greater than 0.34 but smaller than 67, I return paper. And last but not least, if neither is the case, so for all other cases, so for any value above 0.67, I return scissors. So that's how the computer chooses a value. It's simply a random choice, does not take into account what we chose, because of course, like in real life, we want to choose simultaneously without knowing what the other party chose. And therefore now here we can store the computer choice here in a constant by calling getComputerChoice. So now we have both choices stored. Now it's time to find out who won. And for that, I'll add yet another function, which I'll name determine winner or get winner, however you want to call it. And this function, this function should now actually take some arguments. It takes the computer choice, I'll name it C choice here, and the player choice as arguments. And then we just need a if check where we go through the different combinations we have. Now the first combination we have is that the computer choice is equal to the player choice, in which case we have a draw, right? So I want to return draw here, and just as before, if I use string identifiers, I want to use a global constant for that to rule out typos. So here I'll add a result draw constant, which includes that draw value. Then here a result player wins constant, where I maybe store player wins as an identifier. And then result computer wins, where we store computer wins as an identifier. The exact values for these identifiers, of course, are totally up to you. So now with that here, I want to return result draw in the end. Now else if, so if we don't have a draw, we want to find out if the player or the computer won. So here we want to check if, let's say the computer choice is equal to rock and the player choice is equal to, let's say, paper. Then we know the player won, right? Because player chose paper, paper beats rock. So in this case, the player would have won. But of course, that's not the only combination. So we need to add another block, and we can do so by adding the OR operator. Thanks to precedence, this is combined together and then compared to whatever we have after OR. This is exactly what we want, because these two belong together. So that's one possible win condition. If this yields true, then the player won. Another possible win condition is that the computer chose, let's say, paper, and the player chose scissors. Then the player won as well. So here I want to group together all the conditions where the player wins. Let me add the if body thereafter, so the curly braces, and use the auto formatting shortcut to auto format this. Now this also added some parentheses here to make this easier to read. Technically, they're not required. You can add them, and auto formatting will re-add them, but you don't need them here because of precedence. Just want to highlight this again. So let's add the last combination here, and that's that the computer chose scissors, and the player chose rock. In this case, we also won, right? So in all these cases, we won, and therefore here we can return result player wins. Else, we know that the computer won, so we can return result computer wins. So that's now our getWinner function, and now we can call that down there in our anonymous function, which we call when we start the game. I add a winner variable or constant here, since we never assign a new value, and we can call getWinner here and forward the computer choice as a first argument and the player selection or to be in line, we can also name this here player choice, of course, doesn't matter, as a second argument. So this will give us the winner, and for now, I'll just log winner here. Of course, that's not the final output, to see whether that works. So let's save all of that and reload here, start a game, and now let's choose paper, and looks like we won. Now, we don't really see what the computer chose, but we won. That's good, right? So yeah, we'll probably find out what the computer chose later, once we add more code. So let's reload, because right now we can't restart the game in any other way. So let's reload, and let's maybe go for scissors. And looks like the computer also chose that. Well, let's also see if we can lose if I choose rock. Well, computer also chose that. Let's go for rock again. Wow. Computer won now. So looks like the computer chose paper. So that works. Of course, we don't really have the best possible output because we don't really see what the computer chose, but we'll get there. Before we get there, though, let's take a step back and learn more about functions and a different way of creating functions. Now let's have a look at a different way of defining functions. We right now always use the function keyword, no matter if we use the expression syntax, which we have here, or if we use the declaration syntax, which we used earlier, where you just had function, some function, and so on, right? So that were the two ways we used to create functions. Now, whenever you have an anonymous function, you can also use a different syntax. And for that syntax here, let's start with getWinner. You can remove the function keyword, and now we would get an error. But now you add, between the parameter list and the function body, you add an equal sign and a greater than sign. So that looks like an arrow here, right? It's an equal sign and a greater than sign without a white space in between. That would be a syntax error. So there must not be any white space between. And this is now a special keyword in the end, understood by JavaScript, has nothing to do with the assignment operator or the greater than operator. So this combined is a new keyword just made up of, well, mathematical signs, I guess. And this constructs a so-called arrow function. And I guess you can see where the name is coming from. So what's special about such an arrow function? Well, obviously, we build it in a different way. There also is only this expression syntax. So where you could use function, some function like this, there is no equivalent for arrow functions. So you can't define an arrow function like this. I mean, you can, but it's not doing anything. It has no name. You can't assign a name to it. You always have to store it in some variable or use it in a place where you would use an anonymous function. So it's an anonymous function where you can't assign a name in any way. So you always use it on the right side of the equal sign or in places like down here with the event listener. So whenever you need to pass in a function and whenever you can use an anonymous function. So that's, of course, one striking difference, and this might sound more like a disadvantage than an advantage. Well, the advantage is it's a bit shorter, you save the extra function keyword, and obviously that's not much to type, but it's a bit shorter. But in addition to that, this function syntax has some extra tricks up on its sleeve. Now, there's one neat behavior which we'll only understand a bit later, related to objects and how arrow functions can help us there. So we'll come back to that later. But even without object and without that thing, there already are some nice things we can do with it. For example, you can shorten this code here in a very convenient way when using such an arrow function. Let's write this code as a ternary expression. And that's kind of borderline because it will be a rather long and a bit nested ternary expression, but you can do it. So you could write a ternary expression, which you immediately return, so where you return the result, where you make this comparison, like that. And if that's true, you obviously return result draw, right? That's how a ternary expression works. Condition, then your result if that is true. And then an else case, and now in that else case, we add yet another ternary expression, so yet another condition, which is this longer condition. And as I said, this will be a bit of a longer ternary expression, but still should be okay. So let's add this condition here, and then another question mark for the case that this condition is met, and that would be result player wins. And then a colon with the else case, so if that condition here is false, and that's result computer wins. Now add a semicolon, And we can now also comment out this if-else block. Now, don't get me wrong, there's nothing wrong with that block. I just want to show you something. So let's auto-format this code. Already makes it much more readable. And now we have this code. Now, I wouldn't argue that this is a bit more readable, but this is also still fine. Shouldn't be too hard to understand what's going on here. Now, where's the advantage? Well, if you have a function, an arrow function, where you only have one expression in it, you can actually omit the curly braces, so you can get rid of that. And also, you then have to omit the return keyword. So you can write this entire function in the end like this here, right? It's automatically restructured in a new line, but this continues here after the arrow. This belongs to the function. So this is as if it would be in one long line. Gets even clearer if we quickly add another function, which we don't need here. Let's say an add function, which also takes a and b as arguments. Then you could write this as just a plus b. The equivalent, add to, with the function keyword, would be that you have to write a, b, and then in here return a plus b. Now, that's not that much longer, but this here certainly is shorter. And especially in places where you just need to pass an anonymous function to quickly do some calculation, this is way shorter than if you have to write this. Now, as always, it's not like this being awfully wrong, but saving some code, and therefore saving some time writing code, is never a bad idea in JavaScript. So along with other advantages, which we'll fully understand later, the availability of extra syntactical sugar like this, where we can shorten this function, is definitely nice to have. Now there's more we can do with that arrow function. So for arrow functions, the general syntax is this one. You have your list of arguments. Of course, you don't need to accept any, but if you do, then you write it like this. Then this arrow, and then your function body. Now, in cases where you have no arguments, you write this like this. You have to have your empty pair of parentheses here. You must not omit this. So this is required. This is how you would write this function if it gets no arguments. Now, a nice other feature, which I haven't shown you yet, is if you get exactly one argument, not two, not none, but one, then you can write it like this. So then you can omit the parentheses. Again, saving some extra code that needs to be written. So parentheses can be omitted in this case. You also can add them, but you also can omit them. Now, if you have exactly one expression in the function body, that's what I just showed you, then you can write it like this. You can omit the curly braces. You don't have to, but you can. If you omit them, though, you also must remove any return keyword or any return statement you had in there, and the result of this calculation will then always be returned. So even if you have an expression in there where you're not interested in the return value, it still will be returned. That might not be a problem, it's just something to be aware of. There always is an invisible return keyword in front of that part after the arrow, so in front of your function body. And also keep in mind, this only is allowed if you have exactly one expression on the right side, so one expression that yields some kind of value. If you have an if statement in there, so anything which wouldn't work after a normal equal sign, that won't work here as well. So if you have more than one expression in the function body, you have to add curly braces, and of course you would write this over multiple lines. I'm just running out of space on this slide, so you would write your code as normal in the other functions as well. So the curly braces and a return statement, if you need one, is required. It's not implicitly returned, and you can't omit the curly braces. So that are arrow functions. Again, they also have one other advantage, which we'll see later. But even without that advantage, it's quite nice to have them because of all that potential for saving some code. And saving one character here or there might not sound like a big deal, but overall it reduces the time you need to write code, giving you more time to think about the real problems you want to solve with your code. And it also leads to shorter code, which often is easier to skip through, easier to read. Not always, but often. So therefore I will actually heavily use arrow functions here, but you don't have to do that. It's again up to you which syntax you prefer. I'm personally a fan of arrow functions here, and here therefore I will convert all these functions to arrow functions. So by removing the function keyword and then adding the arrow between the parameter list and the function body. As you learned, here if you take no arguments, if you have no parameters, you need that empty pair of parentheses. So with that, let's also remove it here and add an arrow here in the anonymous function in the event listener. Auto format everything, and yeah, that's looking good. Arrow functions everywhere. Let's work on our game a little bit more. We get the winner, but we get now extra information about the winner, right? We know that the player won, but we don't output any other information. So what I'll do instead is I'll add more code down there in my game is running logic, because I want to control which message we output to the user. So we can add another if statement here and check if winner is equal to result draw, which means we have no winner. In that case, I want to create a message, and actually that message will be different for other cases. So I'll create it in front of the if statement, because as you learned, if you would create it inside of the if statement, a variable here would only be available in this if block, because let and const create block scoped variables. So in order to have a variable which we can access from any block of our if statement, so also from the else if branches, we need to create it ahead of time. And I'll name it just message. And then here I set message equal to a string created with backticks so that I can inject some dynamic values. And there we can say you picked, and then inject the player choice, which will be rock, paper, or scissors. And computer picked, and then input the computer choice here. Therefore, you, in this case, had a draw, right? Because that's what's happening here. So that's my message here. We had a draw. Now let's move on. In the else if block here, we can check if winner is equal to result player wins, which means we won. In this case, I also want to construct a message, so we can actually copy that. And yes, we could also write this in a more reusable way. You could also grab this message here, cut it, and initialize the message up here with that string. And only that last part, where we have therefore you, and then here we want to exchange this. So here we end with just you white space, and then here we set message equal to message plus had a draw in this case to add this. And now here in this else if case we say won, right, because the player won here. And else in the last case, which is that the computer won, we set message equal to message plus lost. And we'll only ever make it in one of these blocks. So these different parts will not be concatenated after each other, but only be added to the space message here. So with that, we're building that message, and I do so that I can show this to the user by calling the built-in alert function here, passing message to it, and this will show the user, well, that the game is over and we had a draw, won or lost. Now, since the game is over, I then also want to set game is running to false here, which essentially means we can now click the button again to start a new game. So here we set it to true, then we execute all these steps, and then we set it to false again. So now with that, if we saved it, let's go back, reload here, start a game, maybe pick rock, and you picked rock, computer also picked rock, therefore we had a draw. Okay, let's click start game again, which should work now. Now rock, computer picked paper, therefore we lost, makes sense. Let's start another game, maybe go with paper this time. Computer also picked paper, so we had a draw. So let's go with paper again, another draw. So let's give that another try. And now we won because the computer picked rock. So this seems to work, all this logic works, the game is finished, but we're not entirely finished with functions. So what else is there to functions? Well, how about default arguments? We have functions that take arguments, like this one, our getWinner function. And right now, this function will produce unwanted results if we don't pass values to all arguments. Now let's actually give this a try. Let's say if the user doesn't pick rock, paper, scissors because he entered something wrong, anything like that, well, then we don't want to return this default user choice here. Instead, we just return here, which means we stop function execution. We won't reach this line, but we therefore basically return undefined. We return nothing, and that will be treated as undefined in the place where we call this function and try to work with the returned value. So we return nothing here if the user didn't choose anything. Now, of course, I still want to have that default user choice, and we could have left the code as it is, but to also show you that feature of default arguments, I'll go with this route now. So nothing is returned here, and that means that down there in player choice, this might be undefined, right? Because maybe this doesn't return anything. So right now, if I save that and I reload, and I start a new game and I click enter something, click OK, this is not true as we know. Instead, undefined is returned, and indeed here we see you picked undefined, and the computer picked paper, and since this leads to our else case here, we lost. So we, of course, pass undefined to get winner because our player choice is undefined here. Now let's alter this code a little bit as well. Let's add an if statement and say if player choice, if it's set, then I want to derive the winner like this. So I'll move that code into this if block. And therefore, actually, I'll create my winner variable outside of that and just assign a value to it here because of that block scoping, so that the winner variable is not just available in here, but also outside of the if block. And now here in the else case, so if player choice is not set, if it is undefined, I'll set winner equal to get winner, and I only call this with computer choice. So I don't forward player choice because this is undefined. We know it's not useful to that function anyways. Now the first interesting thing which will happen here, and by the way, that's totally independent of whether you're using arrow functions, you're using function expressions with the function keyword, or function declarations. This will always work like I show it to you now. So the first interesting thing is actually that I reload here and I start a game, enter something invalid, click OK, and we still get that same message as before. So the interesting thing is that we don't get an error. In a lot of other programming languages, you would get an error, because what we're doing here is we're calling a function, getWinner, which actually expects two arguments, two parameters, and we're only passing one. Now, JavaScript, as you learned already, is a quite forgiving language. Other languages are not as forgiving, and there you would get an error, because in the end what you're doing is you're calling a function in an incorrect way. So JavaScript forgives this mistake, but it then uses undefined as a value for the missing argument, which makes sense, it is not defined, right? Now that's where default arguments come into play. You assign a default value by adding an equal sign here, and then your default value. Like in my case here, default user choice, this constant which in the end points at rock here. So that is something we can do here. This is how we can set a default value. Now with that, we just have to alter the code down there a little bit. Player choice, of course, still would be undefined because we never changed the value that's stored in there deliberately, because I want to show you that other approach. So here we can add a short ternary expression, check if player choice is truthy. If it is, use player choice. Otherwise, use the default user choice, or as you learned, if that's what you want to do, you essentially can use the OR operator, and if that is a truthy value, it will keep that. If it's not, it will return this. So now we can save that, reload, enter something incorrect here, and see rock was picked. So this works, and now just to again clarify this, obviously the previous approach of just returning a default value up there in getPlayerChoice was shorter. It is probably the approach you would use normally. But this is a nice way for me to show you default arguments, which come in handy in many places where you have a function that can be called in one way or another. And then having these default arguments can be really, really nice. Now let's dive a bit deeper into default arguments and what you can do with them. For one, let's see what happens if I actually would pass in my undefined value here. So I'm forwarding player choice here. I'm considering the choice the player made, which will be undefined. And therefore, please keep in mind that what we're going to output down there will not be what we pass in here, because we pass in undefined here. And therefore, hopefully, we take our default argument. Here at the bottom, I definitely output that we took our default argument, even though we don't yet know how this will behave here. But to find out how our function behaves, we can use the developer tools. Let's go into our browser, reload, sources, and then there to app.js. And in app.js, let's simply place a little marker inside of the getWinner function. And now click that button here, enter some garbage. And now this will pause. And if you now hover over pChoice, you see rock was used here. So this has a value of rock, even though player choice, which we're passing in, will be undefined. As you can see, if I zoom out a little bit here so that this is easier to read, as you will be able to see, if I scroll down a little bit here, and I place another breakpoint here right before we alert the winner message if we resume. Now we can get insights into the variables defined here. And indeed, you see the player choice is undefined, right? That's what's happening here. It's undefined. And still, winner did actually use rock as a default. So if you pass, and that's the takeaway, if you pass undefined, and I'll clear these breakpoints, if you pass undefined here as an argument where you have a default argument, then the default argument will be taken, but only for undefined. Other falsy values will not have that effect. So if you would pass a falsy value like null or an empty string or a 0 here, that value would be kept. And especially the 0 shows why that's the case. If you pass in 0, well, you certainly will have some functions where this is a normal value. Let's say you have some add function where you want to add two numbers. Maybe you want to add 0. Might not make the most sense, but you certainly don't want to take some default value in that case. You don't want to override the user's wish of adding a 0. So that's why other falsy values are not replaced with the default argument. Undefined is replaced, however. So passing undefined or omitting the value altogether has the same effect, and the default value comes in. Now, in addition, you also can define arguments, parameters with default values before you have arguments which don't have a default. So if we add cchoice here after this would be valid. In some other programming languages, this is not allowed. There, your parameters with default values always have to be the last ones in the list of parameters. Simply for the reason that these here can be populated with default values, this here can't. So now, for example, if we call getWinner with only one argument here, like we do in this case, this value here will actually be passed in as a value for pchoice. Even though that has a default value, the order of how arguments are getting their values is not changed. And here we pass exactly one argument, and this is at position 1 of our argument list, obviously, since it's the only one. Therefore, the first parameter here will receive it. And it doesn't matter that this parameter would have a default value. JavaScript won't look for other parameters without default values and try to assign your value to those. That would be a pretty bad behavior, because it would mean that JavaScript tries to be smarter than you are, you the developer, and that can lead to a lot of unintended behaviors in your code. So therefore, JavaScript doesn't do that, and hence you can have default arguments before other arguments, but that means that if you only pass one argument here, this one argument is stored in this parameter here, so you get that parameter here, and this will simply be undefined. So that's just something to be aware of. Therefore, in most cases, you automatically have a setup where your default arguments come last, because then you typically have functions where the first arguments always need to be defined, and then the last arguments can maybe be omitted, and therefore you have your default arguments there. Another interesting feature, when assigning a default value, you can even use parameters that came before that parameter. So if this default value should take this parameter into account, you can do so. So you can definitely add this here. Let's say in a ternary expression where you check if this is equal to rock, and in this case, you don't use the default user choice, which would be rock, but you use paper, something like that. This would be valid code. Of course, this is cheat mode now. This means that whenever the computer uses rock, we automatically win. But it's just here to demonstrate what you can do. You can refer to other parameters in your default arguments. Just make sure that the arguments you are referring to came before this parameter where you assign a default argument. So that's it for default arguments. I'll remove this cheat mode here and just make sure we set this default user choice. So if we now reload and enter some garbage here, rock is chosen for us. We had a draw because the computer also picked rock. Now the computer picked scissors, so we won. So that all works. Of course, if we enter a valid value, just to test this as well, then this is taken into account, because then we call the function differently. Then we call it like this. And therefore, this is it for default values, a handy feature which allows you to write more flexible functions. Now that we had a look at an important feature, default arguments, which helps us with writing more flexible functions, let's have a look at another feature. Not really related to our game here, to be honest, but related to functions. So I'll add a brand new function here at the bottom of the file, since it is, as mentioned, not related to the game. And the function here can again be created with one of the three syntaxes you learned. Doesn't matter which one you use, I'll go for the arrow function. And I'll name it SumUp. Now my idea here is that we can pass in as many arguments as we want and build a sum for those. So not an array, but as many arguments as we want. So here I want to have like A, B, C, D, but I want to have an infinite amount of arguments here. That's my idea. And you can see where the problem lies. I can't know when I'm writing this code with how many arguments this function will be called. Well, obviously, I will know if I'm the one calling it here, but let's say this is more dynamic. It's done inside of a loop, which is based on some user input. So anything where we can't fully control how often it will be called. So here I will call it myself in the code, but again, let's assume I'm not the one calling it like this, but instead we wrote some code where this is called dynamically with a different amount of arguments. So we could be calling this with 1, 5, 10, -3, 6, 10, and so on. But I also want to be able to call it with an extra argument or with 2 extra arguments, something like this. So this should be flexible regarding the amounts of arguments it gets. Now, you could think, well, since JavaScript is forgiving and we can have more parameters than we need, we can of course build this function with a lot of parameters in mind and hope that it never gets called with more than that. Well, hope is never something you should rely on. And in addition, you still might run into problems where all unused parameters are undefined. And if you then use this in some mathematical calculation, you will probably get incorrect results or not a number as a result. So this is not really a great solution. Well, another solution would be to simply force the user to pass in an array, right? Something like this. Numbers is an array. Now here we pass an array. Here I don't, but I'll just comment this out for now. And now we can use a loop here, build a sum, start at 0, use our loop, where we go through all the numbers here, with the good old for off loop you learned about, and then simply add each number to the sum, and in the end, we simply return the sum here. Now we have a SumUp function, and if we give that a try and we console log the result of calling that function here, save that and reload, and also avoid this syntax error and use a semicolon instead of a comma, important. So save that and reload, we get 29 here, which is the sum of these numbers, like 6, 16, 13, 19, 29. So this works, and of course, you could kind of implement it like this. Now the thing is, not in all JavaScript programs you're going to write, you might be fine with a solution like this. Maybe you really want to allow that the function is called with multiple arguments, for whatever reason that may be, but you want to make sure that this is the case. In such a case, you can call the so-called REST operator. It looks like the spread operator, which I showed to you in the behind the scenes module. You add 3 dots, but the place where you use that operator is different from the spread operator. You might remember that spread operator was used when you created an object or when you created an array. And then you could use the 3 dots in there to take an existing object or an existing array and pull out all the key value pairs or all the elements of the array and add them to the new object or new array. Now here we use the 3 dots in a different place. We use it in a parameter list. And there, in such a function parameter list, it does something different. Instead of pulling elements out of an array, here it takes all arguments this function gets, and that might be as many as you want, and it merges them into an array. So it builds an array here inside of the function. So now you can call the function without passing an array by having real different arguments, but they're getting merged into an array inside of the function, which you of course don't see when you just call the function. And then we can work with that array and in this case return our sum. So now we can also call this function like this. So with these 2 lines of code I have here at the bottom. This will now work if we save and reload and we get 29 and 142 as sums because of that REST operator, which is really, really useful therefore since it gives you more flexibility when you're writing your functions. Now, and one important note about the REST operator, it always has to be the last argument in your list. For example, if you expect another argument a here, well, then A can never be passed in, right? Because this always consumes all arguments and merges them together in an array. So if you would have arguments after an argument which uses the rest operator, you can never reach that argument. So here we even get an error, therefore rest parameter must be last formal parameter for this exact reason. So this is not allowed. You also can only have one parameter, one rest parameter, I mean, because for the same reason. This automatically merges all arguments together, so there is no room for a second rest parameter. What you can have, though, is parameters in front of this. A, for example, and B, and whatever you want. Because that simply means that the first two arguments in this case, 1 for A and 5 for B, will be assigned to these parameters, and only all the other arguments or parameters thereafter will be merged together. So if we do that, now A and B will be excluded from the calculation, and therefore if we run this, we get different results than before. To be precise, the same result as before, -6, because 1 plus 5 is 6, because that's now not included in the calculation, because it's not included in the numbers array. So you really got a lot of flexibility here with the rest operator. Now a little side note, when not using an arrow function, so when using the function keyword, so let's say we build a subtract up function and now I build it with the function keyword, then you can also use the rest operator there. Nothing wrong with that. You can build it in the exact same way as you do with the arrow function. But here you actually also have another way of building this. So let me copy that code. But of course here now I subtract all the values. So that's the difference between the two functions. And now let me call this. So subtract up. And here I have 1, 10, 15, 20, something like this. Well, now, of course, it would fail because numbers here, what we're looking for, will not be defined. Previously, this was our rest argument, our automatically generated array. Here it's missing. So therefore now, unsurprisingly, if I reload, we'll get a little error here. Now, you can, of course, as I just explained, use the rest parameter here, just as you did it in the arrow function. And if you do so, everything will be fine. We can reload and it works. But now, and that's the blast from the past thing, we can also use something different. In functions created with the function keyword, you have a special variable available, which you never define, which you don't accept as an argument, but which is just magically there, so to say. And that's the arguments variable. Arguments, as you see, is already marked as a keyword because it's built into JavaScript. You can use it inside of functions, but only inside of functions that use the function keyword. And it gives you an array-like object, not a true array, but array-like, with all the arguments this function got. So before the rest operator was introduced, which happened with ES6, this was the way of building a function like this one. So this was then the automatically merged array. So if I now save this, this runs again with -46 as a result. So this is an alternative to using the rest operator. That being said, using the rest parameter is recommended because this is always a bit strange to have this magic arguments thing coming out of nowhere, and it's much cleaner to define this rest parameter. So whilst this does work, no matter if you're using the function keyword or not, you should always use the rest operator. So don't use that. Just wanted to show it to you because you will find it in some JavaScript snippets you might be looking at, and it was the only way of achieving this before this rest operator was introduced. So obviously, thus far, we already have a lot of new pieces of information about functions. What if I would tell you that you can also create functions inside of functions? For example, here in the SumUp function, we could add a new function, again with any of the three function syntaxes you learned. I'll again use the arrow function syntax, but that's not required, where I add a validate number function, something like that. Now this takes a number as an input. Let's maybe name it number, and then does something. Now it's a normal function. The only special thing is that it's part of another function. Now if you think about it, it kind of makes sense though, because what are functions? Essentially objects. And of course you can create an object and store it inside of a function. Then it's locally scoped to this function because of the block scope. Well, nothing else is happening here. We're creating a function inside of a function, and the only difference to all our other functions is that it's now only available inside of this function. All other functions here essentially were created globally, right? I always did it on the root level of my script. And therefore, thanks to normal scoping, these were global scoped and we could use them everywhere. Now I'm simply creating a function which can only be used in this function. And here we could simply check if number is not a number, and if that's the case, replace it with 0 and otherwise keep it. And then we could use validate number here to basically add our validated number here to the sum. If we now reload, it works just as before, but a difference will be if we add something which is not a number, some text here for example. The result will be different than before, obviously, because I removed the number, but we get no error. Without that function, we would get one. But it's not so much about the logic I added here. You can argue if that makes sense or not. The important thing is that this is now a function which is only available inside of this function. Now, should you therefore only create functions inside of functions? It depends. Most of the time, in the vast majority of cases, global functions are the thing which you want, because the way functions work and how you build your code with different functions that depend on each other, you most often have a scenario where you want to work with a lot of global functions and where a function itself might not really call a function that only belongs to it. But you will also have some use cases where this makes sense, and therefore it's nice to know that this exists. We'll dive a bit deeper into functions created inside of functions later when we dive into more of the advanced aspects there, have a look at performance and how the arguments and data you use in there actually behaves. For now, it's just something I wanted to show and make you aware with. As I mentioned, if you think about it, it actually makes sense because functions are just objects which we store in a variable essentially here, in a constant, and therefore of course, just as we can store any other data in a function and scope it to it, the same is possible with functions themselves. So now that we had a look at functions inside of functions, which is quite interesting, let me come back to that add event listener thing. There, I'm passing a function as an argument, an anonymous function which I create here in place as I explained. Now, I already mentioned it at the beginning of this module. What we're effectively doing here, therefore, is we're passing a pointer at a function to another function. So this function here is effectively a parameter or a value for a parameter of the add event listener function. And that's a pattern you will see in JavaScript a lot. You can also build it your own for your own functions, but especially built-in functions will often have this behavior where you need to provide them with a function. Typically, all built-in functions that do something which is event-based or which takes a bit longer. Because this is a pattern called a callback function. In the end, what you're doing here is you're creating a function, either in place with this anonymous function, or you stored it in a constant before, it doesn't matter. And you're just passing a pointer at the function to add event listener. That's what you already learned. Now, you never call the function yourself, right? The browser, so the thing behind add event listener in the end, calls it for you when that click event in this case occurs. Now, this is called a callback function, therefore, because it's called for you by something else. You can't control when exactly it's called. It's just coming back at you. It's called for you at some point in the future. And therefore, this, for example, for events is the core pattern because you can't execute the function on your own. You don't know when the click occurs. You just want to give the browser the function or a pointer at a function to execute for you. That's why in this case, you pass a function as a value for an argument to another function because the browser needs that function to do its job. Hope that makes sense. Now you can also build your own function that takes a function as an argument. Let's say the SumUp function here should actually not return the sum here, but instead it should execute a function which we pass to it, which then gets the sum as an argument. So I'll replace a and b here with a new parameter, and you can name it however you want. You'll often see names like cb for callback, but you can name it however you want. So I'll name it result handler to make it really clear that this is kind of a function which will do something with the result of this calculation. So here, once we're done, instead of returning, I'll use this result handler parameter. And since it will be a function or a pointer at a function, I can execute it as a function by adding parentheses, right? Hope that makes sense. It will be a function, so I can execute it as such. Now we'll pass sum to that function. It's now our job to make sure that when we call SumUp, we do provide this function. So for this, I'll actually create yet another new function here. show result, or however you want to call it, with any of the three ways of building a function you want. Again, that does not matter here. Whoops, I'm missing a semicolon here, by the way, now that I saw it. So show result like this. And there I want to use the alert function to show the result. The result after adding all numbers is, and then simply show the sum here, or the result. So I expect to get the result here in this show result function as an argument, and therefore I can use it here. And I can expect that I get it as an argument here, because this will be the function which I pass to sum up in the end as a first argument, and therefore that will be what is used as a result handler. That will be called, and an argument will be passed to it. So sum, which is passed to result handler here, will in the end be the argument I receive here in show result, because show result is now what I pass to sum up as a first argument. Of course, without parentheses, just as we did it for add event listener, because I don't want to execute it here, I want to give sum up the chance of executing it for me. So I pass show result here to both sum up and to the other sum up call, not to subtract up, because there we don't support this yet, but pass it to sum up like this as a first argument. Therefore, in sum up, this is received here on this result handler parameter. So this is now a pointer at a function, therefore we execute it here, and we pass sum to it. And since the function that will be executed is this function, sum will in the end be the value for a result here and will show up in our alert. That's the theory, at least. Let's give this a try and let's reload this page, and indeed I get an alert with 19 and 142. And I get undefined here because I still console log the result. Now, since SumUp doesn't return anything anymore, this won't work, so we should get rid of that. And instead take advantage of our show result function, which we now pass. So this is a callback function and how we can build it on our own. Now, again, this is how you can build it on your own. Often, or in a lot of cases, you won't need to build it on your own. Because of course here, there's nothing wrong with just returning the sum here and then using it in the place where you called SumUp. But throughout your career as a web developer, as a JavaScript developer, you will also encounter cases where you want to write functions which actually take such a callback function and then do something with it. And a lot of the built-in functions in JavaScript support this pattern, especially all the event listeners and so on. So everything that's related to actions which occur in an unpredictable way or which take very long. And therefore here it's nice to know what's happening behind the scenes when you use these internal functions like add event listener, right? Because that's exactly the pattern we use there. There I'm passing in an anonymous function, but as you learned, that's essentially the same as pointing at a named function like this. So the nice thing is we have the show result function and we can pass it around as a callback. Let's now say we also want to use the same pattern in subtract up. So I'll leave arguments here just for you as a reference. Of course, you could use a REST parameter here. I'll not do it here, but what I will do is I'll also expect a result handler here. So just as in SumUp here, I want to get a result handler, and instead of returning the sum, I want to call result handler and forward the sum to it. Okay, so now we can get rid of the console log statement down there and simply pass show result as our first argument, effectively using the same approach as we did for SumUp. So that's what we just learned in the last lecture. If you now reload, you get 19, 142, and not a number actually. Well, we get that because of that arguments thing. Actually, therefore, we have to switch to the REST parameter now, because result handler is one of the arguments, so we try to include that in our sum, which of course won't work. So let's switch to the REST parameter approach. A good example for why you might want to use that and not use arguments, now that I see it. So that's actually not the main thing I wanted to show, but still nice to see here. But now with that changed, let's reload and give this another try. We get the right result, but what you'll also see is that I still say after adding all numbers. Well, of course, here we're not adding any numbers, we're subtracting them. So we want to change the message, but if I change it here, it will be changed for SumUp as well. Now, of course, we could create a new function here. We could create show result 2, where we have a different message and use show result 2 here and show result there. That would work, but you probably see that you would create a bunch of different functions just to show a different message. Now, a convenient way would be if we could actually get two arguments here in show result. One is the result, and the other is the message text, let's say. So that in the end here, we only combine message text, and then maybe some white space, and then result. And here we want to make sure that message text is the result after adding, blah, 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 and here it's the result after subtracting, blah, blah, blah. So that's our goal. Now we just have a problem. Result is passed in here in result handler. The sum is result, and here as well. Now, of course, here we could define the messages, because here we know it's in sum up, so we always want to provide the result after adding all numbers is as a message. We actually know this here because we have our two different functions, sum up and subtract up, right? Now, what if that were a more reusable function, where we have one function that does either sum or subtract based on some other parameter we're getting? Actually, we can even simulate this here. Let me comment out subtract up, and instead here, add a new operation parameter to sum up, and therefore I'll just name it combine. So now we got this new operation operator, and here in the loop I can check if operation is, let's say, sum, and yes, you could use a global constant for that, in which case I'll update the sum like this, add I mean, or else it's probably subtract or whatever, else we therefore update it like this, so with a minus. So now we have a more reusable combine function, and we can replace sum up and subtract up with that down there. Then here pass add as a second argument. That's this extra operation argument which is now expected, and here it could be subtract. So now if we do that and we save this and we reload, it works as before, but still with the wrong message. Now, of course, we could adjust the message down there, for example, with a ternary expression, and check operation if it's equal to add, in which case we show message A or message B. But the more possible operations we support here, the more cumbersome this gets. So in the end, I just want to pass my sum to result handler. And it would be better if we could set up the message down there where we know which operation will be performed. And that's exactly what we'll solve now. Of course, we could easily pass our message if we would call the function here, but we don't want to call it here. We want to give it to combine so that combine calls it for us. So that's not an option. So what can we do? Well, functions are objects, and they actually have special properties attached to them, or to be precise, special methods here. And one method is the bind method. Now, you just call .bind as a method on your function object, and you do execute this, and what bind will do is it will create a new function, a new reference at a function which it returns to you, which will be pre-configured regarding the arguments it receives, and that's the interesting part. So with bind you can create a function which is not immediately executed, what would be the case if you manually call it like this, but instead which is prepared for a future execution, where certain values for certain parameters, which you already know at this point of time, are already set. So how does this now work? Well, bind takes at least two arguments. The first argument is one we have to ignore for now. It sets a value for a thing called this, a special keyword in JavaScript, which we haven't learned about yet, which we will learn about in the objects deep dive section. For now, you can pass in this here, just like that, the this keyword, and ignore it for now. Then, separated by a comma, you pass in the first parameter you want to pre-configure. And you can pass in as many as you want. You can pre-configure as many parameters as you want, and as your function supports, of course. So here we could say the result after adding all numbers is like this, and copy that to my other two calls down there as well. Now for subtracting, of course, I'll change it after subtracting all numbers. So I change it to that. And restructure this across multiple lines. Bit strange. Yeah, we'll go with that. So now every argument has its own line, I guess. So now we call combine 3 times, and we bind this value here to show result. Again, this does not execute show result immediately. It just prepares it for execution. Now, the thing is, the arguments you're passing here, in our case, one argument, will be received in exactly that order. Now, showResult, however, expects result as a first argument, and we're not providing a value for that here at all, and we can't, because that will be derived in the combine function. Well, we just have to swap order of arguments here in showResult, so that message text is the first argument, because it's the first argument we're setting here. And the good thing is, we'll still get result here, because the place where you actually call showResult, so in our case inside of combine here, in this line, the value you pass to result handler here will automatically be appended as the last argument or arguments in your function. So if you bind and set your own arguments, these will always come first, and any arguments which are then passed in the place where you actually call this function will come after your own configured arguments. So showResult will receive both the message text, because you're setting it here, and result, because when we pass it here, this will automatically be appended at the end of this parameter list by JavaScript. And that all happens because of this bind method. So with that, if we save that and we reload our page here, we see the messages after adding all numbers, and again after adding all numbers, but then after subtracting all numbers. So it works exactly as it should, thanks to the help of bind, which allows us to pre-configure functions in places where we need to pass in a value, but we also don't want to directly execute a function. By the way, a place where this would have helped us is in our app from module 2, from the basics module, where we also have a couple of add listeners for adding, subtracting, multiplying, and so on. And we have to bind them to different functions here, because whilst a lot of code is the same, we have some differences here regarding the operation we perform and what we write to a log. Now, with if statements and dynamically bound values here, we could have merged this all into one function, which I quickly want to show you. Here we could add a calculate function. And again, you can use either function syntax. Since I always use the function declaration syntax in this file here, I'll stick to it. And there you could actually expect a value, let's say operation parameter again, where you check if operation is equal to add, and you can use global constants, of course. And if that is the case, then what you do is you perform this calculation. Else, if operation is equal to subtract, and you could use a switch case statement in this example too, by the way, you would do the same. Here I see I copied the wrong code. Of course, I want to copy the code from add here. So let me do that. That will be replaced here. So we have the add code, we have the subtract code here. Else, if operation is equal to multiply, if that's the case, then we grab this multiplication code here, like this. And in the else block that has to be the division, we grab that division code here, like that. And now let's just grab that code, which is always the same, where we get the entered number and the initial result, like this. And now we have this all in one function. We can even shorten this a bit more by adding a new variable, operator, which we then set to a plus here, and which we set to a minus here, and which we set to times here, and which we set to this divide operator here. And that allows us to basically grab all the create and write output calls here, and write to log calls, and remove them from there, move that out of the else if block, and here use the operator variable we just worked on. Here we can use the operation, which I expect to get as an argument, because that should be add, subtract, multiply, and so on. And therefore now we have this all-in-one function, which we now just have to bind down there. So we always call calculate, but we just have to make sure that a different value is passed in for operation. And that's now super easy to do. We can just call bind here, this, again, ignoring what this does. And then here we pass add, and so on. So down there we pass in subtract. Here we pass in multiply. And here we pass in the void. And now we can actually delete all the other functions here, so add, subtract, and so on, and just go with calculate. And if we save that and we reload, we'll have a calculator that works exactly as before, but now with the help of bind and if statements. So this is now a way more concise way of writing this, and it hopefully also shows why this might be useful to have, why this might be nice to have. Back to the code we worked on before. Bind is a really useful function, or method to be precise, which you will use quite often as a JavaScript developer to prepare your to-be-called functions, which you don't call yourselves. Now, there are similar functions which you often find when you research the bind method, and that is the call and the apply method. Now, essentially, they also allow you to specify what should be passed in as parameters, but they also immediately execute the function. And that's, of course, not what bind does. This prepares the function. Apply and call immediately execute the function, and there also is a difference between apply and call. But since also this part with immediately executing a function isn't really helpful to us right now, because we can always call a function like this if we want to immediately execute it, we'll ignore apply and call for now and dive into them later when we actually understand what their use is. There's not much sense in doing this right now. Just wanted to already throw their names in there so that you are aware of them if you research on your own and you stumble over them. Bind is really useful for us right now, and of the three, the one which you will use the most often, because being able to prepare functions is really, really valuable. So that's it for functions. Quite a lot of content, quite a lot of different ways of creating and configuring and using functions. You learned about the function expression syntax with the function keyword or with the arrow function. You learned how arrow functions work and the different ways of using them, different ways of shortening the code, which is always nice. You learned about default arguments, which can be quite handy. Same is true for REST parameters, which allows you to merge parameters together into an array, which you then can use. And both default arguments and REST parameters, or REST arguments, are really great features for allowing you to write more reusable or more flexible functions that can be used in different ways. You also learned about bind, which is super important for preparing functions which you're not executing on your own, but which will be executed on your behalf, like, for example, with an event listener, or as here, in your own function, where you use this callback function pattern, where you receive a function as an argument, which you then call from inside that function. We also touched on functions being created inside of functions, something which you can do, which you don't need to do that often right now, and which we'll dive deeper into later, also dive into performance implications and so on, once we're a little bit more advanced with JavaScript. For now, I'd say that's more than enough. A lot of function features covered, which you'll of course see throughout the course here and then, and which you will also probably need in some of your projects and see in other projects you might be participating in or you're analyzing. So with that, more core features learned. Let's go ahead and dive deeper into JavaScript and actually leave the pure syntax part here, because we're already pretty good on that, and instead now also have a look at how we can actually interact with the web page. Something I previously always provided to you. I always gave you that connection. Now it's time for us to learn how that actually works.